Myself, Purva Joshi, Assistant Professor at LG Institute of Engineering and Technology. Today we will discuss the topic Taylor and Maclaurin series. In this topic, first we will discuss some basic derivative formula. Then we will discuss Taylor series in powers of x minus a. Then we will discuss few examples related to this topic. So let's begin with the first one, that is prerequisites. So we will learn here some basic derivative formula. The first one is the derivative of constant, that is 0. The next one is derivative of x, that is 1. Derivative of kx, which is k. Derivative of x raised to n, that is n x raised to n minus 1. Next we will see the derivative of log and exponential function. So the first one is the derivative of e raised to x, that is e raised to x. Derivative of ln x, that is 1 upon x. Derivative of e raised to x is e raised to x log a. Derivative of x raised to x is x raised to x into 1 plus ln x. Next we will see the derivative of our trigonometry functions. These are the important derivative you have to remember. So first one is the derivative of sin x, that is cos x. Next is derivative of cos x, that is minus sin x. Derivative of tan x, that is sec square x. Derivative of cot x, that is minus cos x square x. Derivative of sec x is sec x tan x, and derivative of cosec x is minus cosec x cot x. Also we will see the derivative of inverse trigonometry function. So the first one is sin inverse x, cos inverse x, tan inverse x, cot inverse x, sec inverse x and cosec inverse x. These are the derivative you have to remember. Okay. Next we will see the product rule of a two function fx and gx. Also quotient rule, that is division rule, which you have already studied in standard 12. Also this chain rule, this also you have studied. Now you have to also remember this table, which consists the value of the function sine, cos and tan at the angle 0, 30 degree, 45 degree, 60 degree and 90 degree. Okay. Now let's begin with the first one, that is Taylor series in powers of x minus a. So firstly we will see the statement. The statement is, if function fx possesses derivative of all order at a, then f of x is equals to f of a plus x minus a upon 1 factorial into f dash a plus x minus a whole square upon 2 factorial f double dash a and so on, plus up to here nth term is written, that is x minus a raised to n upon n factorial into f raised to n at a. So we'll see its proof. So whenever we have to prove something, so firstly we'll assume. So firstly suppose that fx can be expressed in ascending powers of x minus a. We are supposing this. So fx we are writing as a0 plus a1 x minus a plus a2 x minus a whole square plus a3 x minus a whole cube and so on. Here the terms a0, a1, a2, a3, these are constants. Okay, so this we have supposed and we have to give name, it's 1. Now what we will do, we will find its derivative with respect to x. So firstly we will take derivative with respect to x. Now here you can see the first term a0, that is constant, so its derivative is 0. Now the next term a1 into x minus a, so its derivative with respect to x is a1. Next we have to take again derivative, so it will become 2a2 into x minus a plus next one will be 3a3 x minus a whole square and plus so on. Give it number 2. Next we have to find again its derivative, right? So first one a1 is constant, so its derivative is 0. The second term, so its derivative will become 2a2. Third term derivative, it will become 6a3 x minus a and so on, right? What we have done is we have to just take derivative with respect to x. Again we have to find its third derivative and so on, we have to find its derivative. Now what we will do is we will put x is equal to a in our equation number 1, 2, 3 and 4 to get the value of constants. Okay, so from the first one we will get f of a is equal to a0. From next, that is f dash of a is equal to a1. Next one f double dash of a, that is 2a2. Here we have to find the constant. Okay, so we'll make A2 as a subject. So A2 will be f double dash A upon 2, and 2 we will write as 2 factorial. Next, f3 of A, that is 6A3. Okay, make A3 as a subject. So A3 will be f3 of A upon 6. Now 6 we will write as 3 factorial and so on. So in general we'll get the an term, that is f raised to n A upon n factorial. Now what we will do, we'll substitute the value of A0, A1, A2, A3 in our first equation, right? So we have to substitute. Okay, so in place of A0 we have f of A, in place of A1 we have f dash A, in place of A2 we have f double dash A upon 2 factorial and so on. So just we have to substitute the value of A0, A1, A2, A3 and so on, and we'll get the final proof, that is the Taylor series in powers of x minus A. You have to remember this formula, which will help in solving sums. Okay, now let's begin with the example. First example is, find Taylor series of a function fx equals to x raised to 5 plus 2x raised to 4 minus x square plus x plus 1 in powers of x plus 1. So first thing I want to tell you is that whenever we have a polynomial function, we will take the derivative until we get answer 0. I'll explain properly in the example. Now, as in the question you can see, we have to expand in powers of x plus 1. So we will compare this x plus 1 with x minus a, because we have the formula in powers of x minus a. So just compare it, so you will get a is equal to minus 1. Now what we have to do, we have to take function fx, we have to take its derivative, and we have to take derivative up till then we get answer 0. Okay, so let's see the function fx. Okay, so function fx, that is the question given. Then we have to find its derivative, that is f dash x. Okay, so f dash x will be what? 5x raised to 4 plus 8x cube minus 2x plus 1. Okay, then again we have to take its derivative. So derivative will be 20x cube plus 24x square minus 2. Then again we have to take derivative, right? You can see here we get the sixth derivative 0. So we will stop here. Okay, so whenever a polynomial function is given, we have to solve until you get answer 0. Now we have to find the value of this function at the point A, and here A is minus 1. So firstly we will find f of minus 1. So in place of x we have to substitute minus 1. So just substitute minus 1, right? So first answer you will get answer 0. Next, in f dash of x, so again in place of x we have to substitute minus 1. So substitute minus 1, you will get answer 0. Next, in f double dash of x, in place of x you have to write minus 1. On solving you will get answer 2. Similarly, you will get answer 12, minus 72, 120 and last one 0. Now what we will do, we have the main formula Taylor series in powers of x minus a, right? This fx is equals to f of a plus x minus a upon 1 factorial f dash a plus x minus a whole square upon 2 factorial f double dash a and so on. We will substitute the value of f of a, f dash of a, f double dash of a, f triple dash of a and so on to get the final answer. Now here a is minus 1. So firstly here I have substituted in place of a. Everywhere in the above equation you can see wherever there is a, I have just written minus 1. So that x minus a will become x plus 1. You can see. Okay. Now we will substitute its value. So f of minus 1, 0. You can see from the previous slide, right? Then f dash of minus 1, that is 0. Then f double dash of minus 1, 2. 12 minus 72. Right? We have to just substitute the value of this derivative at this particular point. Now what we have to do, we have to just simplify it. Okay, so on simplification you will get the answer f of x is equal to x plus 1 whole square plus 2 into x plus 1 whole cube minus 3 into x plus 1 raised to 4 plus x plus 1 raised to 5, which is our required Taylor series. Okay, we'll see one more example. Here the question is, prove that ln x is equal to x minus 1 minus x minus 1 whole square upon 2 plus x minus 1 whole cube upon 3 plus so on. And this question can be again asked as, find Taylor series of fx is equals to ln x in powers of x minus 1. And here it is asked that we have to find its value at ln 1.1. Okay, so question can be asked in any form, solution will be same. Now let's see its solution. As you can see here, we have to expand in powers of x minus 1. So to find a, what we have to do, we have to compare this x minus 1 with x minus a. So from this you will get a is equal to 1. Now next step is what? We have to write function fx and we have to find its derivative. Now here function is not a polynomial, so we will find 3 to 4 derivatives. So first fx is ln x, then f dash x. So derivative of ln x is 1 upon x. Then again we have to find derivative. So f double dash x is what? Minus 1 upon x square. F triple dash x is what? 2 upon x cube and so on. Right? Here I have solved up to 4th derivative. Now what we have to do? We have to find its value at a. And here a is what? 1. Right? So in place of x we have to just substitute 1. So ln of 1 is 0. In the next one, f dash of 1 you will get 1, f double dash of 1 minus 1 and so on. Now what we'll do, we'll write the first formula. So f of x is equals to f of a plus x minus a upon 1 factorial, f dash a and so on. Okay. Here a is 1. So in place of a everywhere you have to write 1. Okay. Then we have to write its value. So f of 1 is 0. Then f dash of 1 is 1. F double dash of 1 is minus 1. So just we have to substitute the value of f of 1, f dash 1, f double dash 1 and so on. And then we have to simplify to get the answer. Fx is equals to x minus 1 minus x minus 1 whole square upon 2 plus x minus 1 whole cube upon 3 minus x minus 1 up raised to 4 upon 4. This is what we have to prove. Now next it is asked that we have to find ln 1.1. Now as you can see, f of x is equal to this formula, right? So in place of x we have to write 1.1. So f of 1.1 is what? 1.1 minus 1, then 1.1 minus 1 whole square upon 2. So everywhere in the above equation in place of x we have to write 1.1. We have to just do simple simplification in calculator to get the final answer, that is f of 1.1, that is 0.0953, which is correct up to 4 decimal. Okay. So in all, we had studied Taylor series in powers of x minus a. We saw its proof and we had solved 2 examples. Right? In the example, what we have to do? Firstly, we have to find the value of a, and then we have to take the function fx. We have to find its derivative and find the value at that particular point a. Okay, and at last we have to substitute in the main formula of Taylor series in powers of x minus a, and on simplification you will get the final answer. Thank you for watching.